Good morning. And today, once again, yesterday, I thought I have posted two questions, maybe you have seen as well. And these are the solutions of those questions. So let's do the discussion, see how we deal these type of questions. So um, a mass M and B of identical size but mass 2m move towards each other. Move towards each other, but they have not given whether they are moving along the central line, number one, or they are moving, let's say, some oblique line. This is a two orientation. Either they can move along the central line or they can move along the, not along the central line. So moving towards each other. These are the two cases possible. And they have given the velocity I plus 2j and I minus 3j respectively. So they have given the velocity. Let's say here they have given in vector form. So why this problem is very specific? Because this is given in vector form. Let's say these are the two respective velocity. Let's say the resultant will be go like this. Fine. So this is only assumption we can take as. Now the next important thing is they collide when their line of center is parallel to. Means their line of center means this is the line of center, we can say this is the line of center, and this line they have given as I minus j. Fine. And they have given restitution value this 1 by 2. Find the final velocities after collision. So I told you already this is maybe head on or maybe oblique. And the we can say 100% chance of oblique, 100% chance of oblique, because you can see the velocities and the center velocities, they are not same. That's why this collision is a oblique type. So I thought at this point it is clear ki how they are moving and which type of collision we can consider as. Now the second important point is once you have considering, like once you are talking about collision, so collision once it will occur, so center to center velocity, let's say it will having u1 and u2. Fine. And this velocity is called as velocity of approach. And maybe after collision, let's say they have a random direction v1 and v2. So that is called as velocity of separation. So I thought these two terminology is clear: velocity of approach and velocity of separation after collision. So we can associate this these velocity that is along the central line as velocity of approach velocity of approach upon velocity of separation. Usually it will be denoting by u1 minus u2 upon v2 minus v1. This is what the basic formula of coefficient of restitution. And since they have given restitution, that is inelastic collision, because E value, if E value is equal to 1, so we can say elastic collision, and E value is not equal to 1. So here we can say that is inelastic collision. So I thought these detailing is clear to you. And always remember the velocity along the central line we have considered for the calculation. So let's quickly see. Now there are few important points that I have drawn for your understanding. Please note those points. The point number one, the impact act along the line of, in fact, impulse act along the line of impact. As you know, once the head-on collision take place, only then, I told you already, the central line will be causing the velocity change. And we can say once we will have, now here you can see, once we will have, so this is a central line, and whatever the velocity that going to be changed, that is along it, along the central line. And there is a one line that is called perpendicular to the line of impact. This is a line of impact that is perpendicular. So perpendicular direction velocity won't change. Velocity will not going to change in a perpendicular. So here we can, this is called as line of impact. Line of impact. And here the velocity will change only along the line of impact. And velocity will not change along the line perpendicular to it. I thought this point it is clear. Hence, I have mentioned here the impulse act along the line of impact, along the line joining their centers. Fine. And unit vector along the line joining the impact, as in the given question it is given, the central line will be I minus j. That's why unit vector along the line joining, here you can see this line it is given already. The center, line of center is parallel to, means this is the impact line we can say. Fine. This is the impact line. So what we can say here, unit vector along the line of impact, that is vector upon magnitude of it. Now next line, the velocity component along the line of impact can be calculated using conservation of momentum. Always remember in collision case, we can use a conservation of momentum and restitution equation. These two equations going to give us majority of the answers. Now velocity component perpendicular to the line of impact remains same. I told you the velocity along the line of impact will change, and perpendicular to line impact it will not going to change. Unit vector perpendicular to the line of impact. Now this point is important. Like here we have given the vector I plus j root 2, and the vector that is perpendicular to, the vector that is perpendicular to this given vector, we have to only change the sign. Here whatever the sign it is there, if we change the sign, so we will get the vector that is perpendicular to it. And how we will cross check? If we will take a vector dot So answer will be 0 because two vectors are perpendicular means the dot product will be always 0. So here we have calculated the unit vector that is along line of impact and unit vector that is perpendicular to the line of impact because along that direction velocity will not change. I thought this much concept it is clear to you. Now let's move to the next part. Now this part is important. Fine. Now here what we have done, now to calculate the final velocity component parallel and perpendicular to the line of impact, here we can see, let's say this is the collision going to be take place, and let's say this is perpendicular line of impact. Fine. So along it we have already calculated a cap vector and along perpendicular b cap vector. Let's take let's take let's take the velocity is in any random direction. Let's say this is v1. Fine. Let's say this is v2, and these are the initial velocity as you know. So let's consider as u1 and u2, the initial velocity, and the velocity will going to change after final impact. So how we will calculate which, like in 2D motion I told you, 2D motion it has a two component. Uh, 2D motion it has a two component. Let's say perpendicular and along the line of impact, that is along the line and perpendicular. So how we will calculate these vectors? So basically in vector you have seen the concept that is called as uh, component along the vector B. So basic formula of component along the vector B, basically here we can get the projection. So projection of B along A, suppose we have to calculate, or A along B. Accordingly we can solve. So here this is the vector that is line of impact and we have to take the projection of vector. Fine. So what we have done, we have taken parallel to A, like parallel to A vector. So what we have done here, we have taken the unit vector along, like parallel to A, suppose we have to calculate of B. Fine. So here let me quickly show you. B vector is a perpendicular vector, correct? And A vector, this is a line of impact that we are talking about. So we have taken the component of vector along the line of impact. Fine. Now along the line of impact. So line of impact, I thought it is given. We have calculated the vector B, and here you can check this is vector B. Fine. And vector B component along vector A. So the basic formula would be vector B dot vector A upon mod A. Means along which we have to calculate, we have to take the unit vector. So by this way we can get the vector A, the velocity component along vector A. So once we have taken this dot product, so what we will get? -1 upon root 2. Fine. And similarly, this is my first vector, m1, and this is 2m1. So once we have taken once again the same way, we can get, so these two vectors, we will get the velocity component along the impact. Let's say u1 and u2. And this is along, and parallel to B means perpendicular vector, the same m1 and m2. So by this way, we got the perpendicular vector of both. Let's say ux, x, and this component will become uy. and u1. So I hope this much point it is clear to you. So this is a very good technique through which we have calculated the given velocity vector along these two directions. So let me show it to you once again. This is the two, and let me show you quickly about with respect to the diagram. Once again, let's say these are the two vector and having this impact line that is denoting by a cap. Let's say this is a vector that is perpendicular to it. Let's say this is vector v cap, and this is the velocity vector respectively. Let's say let's say u1 and u2, and initially, like here we can say, initially it has a two component, and how we have calculated the two components in direction they have given. We have drawn the using the projection formula or component through which we have calculated u1, u2, that is x direction, and u2 y direction, and u1 y direction. These components we have calculated, and these are the component respectively. Fine. Now here important thing is when the impact going to be take place, so which vector will affect? Which vector will affect? So here we can say these two vector will affect. So let's say the final velocity will be v1 and v2 along the line of impact, because u1 and u2, u1y that is will not change, and u2y it will also not change. Fine, these two vector will not change. Now, now here, this is the basic composition. I thought you will get it quickly. Now here, I told you these are the two velocities. Let me draw it once again quickly. U1, U2. Fine. If we make a component, so these two component, I'm denoting, well, these are two perpendicular, and these are the along the impact line that is denoting by here. Let's say the final velocity will be V1 and V2. This is what it is clear to you. Now I'm using the law of conservation of momentum. So M1 V1 plus M2 V2, that is equal to initial momentum P initial, and this is equal to P final. P final 2M1 V1 plus M2 V2. Now by this way we can get equation 1, and the next velocity, I told you velocity second equation we will get with the help of coefficient of restitution. So final velocity v2 minus velocity of separation is equal to half velocity of approach. So with the help of these two equations, we can get the v1 and v2. Now here you can see v1 and v2 we got. So once we have got the v1 and v2, so now we can once again substitute the value of v1 and v2. So let's say for 2m, let's say for 2m, v1 is 5 upon 2 root 2, and v2 is 2 root 2. So don't you feel we have two vector that is along impact and that is perpendicular to impact? Once we have taken the resultant, so we will get the resultant velocity of m2 and resultant velocity of m1. So here you can see the next, here we have calculated the resultant velocity of m and resultant velocity of 2m. Fine. So once we get the resultant velocity of m and 2m, so these are the respectively the velocities of m and 2m in vector form. And if you are looking for total velocity, to total velocity we can take the square and under root, so we can get the resultant velocity. So this problem, it was very interesting, and look at the calculation tool through which I have proceeded. Here I have using the vector algebra and up to their extreme extent. So just make you realize this question look like difficult, but it is not that difficult once you will do and use this method. Till then, take care. We will bring the next problem solution soon, pushing yourself so you can get your favorable IIT. Take care.